Alright, practice problem 10.14 says when a sample of potassium chlorate is partially decomposed in the setup shown in the figure below, okay, the volume of the gas collected is 0.25 liters at 26 degrees Celsius and 765 torr total pressure. So part A says how many moles of oxygen are collected. So if we think about this, then we're looking at the total pressure, okay? So if we look at P total would just be equal to the pressure of the oxygen plus the pressure of H2O. Okay? Okay, so let's also think about the equation that's taken place here. So we have KClO3, which is being decomposed, okay, into potassium chloride, which is going to be a solid, plus oxygen gas. Okay, and so if we balance this equation, we basically have a 2 here, a 2 there, and a 3 here. All right. So if we go back to this first problem, which asks how many moles of oxygen are collected, we first need to find out, well, what's the pressure of oxygen, okay? Alright, so we know that the total pressure, it tells us, is 765 torr, okay, and that's shown up here. Alright, so if we go back up to our equation up here, we have 765 is equal to the pressure of O2 plus the pressure of water, okay? And so basically we can see that we have vapor pressures at different temperatures shown down here, okay? And so if we actually just replace the pressure of water, okay, which we're given the vapor pressure at 26 degrees, which is what it asked for, which is going to be about 25, okay, and we can go with 25, that's fine, torr. Then we know that the pressure of O2 is just equal to 765 minus 25, and so that's equal to 740 torr. So now we're looking for how many moles of oxygen are collected. Well, we know we're looking for N of O2, which is just going to be equal to the pressure of O2 times the volume divided by RT. So PV equals nRT just rearranged. And so here we have 740 torr times the volume, okay, which is we first need to convert the 760 torr, right, to atmospheres. So 760 torr in 1 atmosphere times the volume, which we're given is 0.25 liters, okay, and we're dividing that by R, which is 0.0821 liter atmospheres per mole Kelvin. Okay, by this point you probably have that memorized, times the temperature, which is 26 degrees Celsius, so 273 plus 26. Alright, and so when we solve for this, you should get 9.92 times 10 to the minus third moles of O2. So that's part A. Part B says how many grams of KClO3 were decomposed. Well, this just goes back to like the last problem where we're looking at stoichiometry, and so we're starting with 9.92 times 10 to the minus 3 moles of O2 times, we have 3 moles of O2 for every 2 moles of KClO3. So 3 moles of O2 for 2 moles of KClO3. And then we want to know the number of grams. So in 1 mole of KClO3, we have a total of 122.6 grams of KClO3. So our moles, all cancel. And so you end up with 0.811 grams of KClO3.